Welcome back to my channel, everyone. Street Tips here, and what we have under this rain cover is my waste treatment bucket. This bucket is full of iron, angle iron, and I add my copper nitrate solution to this bucket and cement the copper out onto pieces of angle iron in this bucket. That's all copper that's been cemented out onto pieces of iron in my waste treatment bucket. This orange bucket will have iron in solution. All the copper and all the precious metals are out of this solution now. What I'll do is I'll treat this with sodium hydroxide to drop the iron out of solution. And what I'll end up with is metal hydroxides and a caustic solution that can be easily treated and disposed of. But for right now, what we're going to do is take this in and we're going to put some more copper in here. Here we go. Here's a look at the waste treatment bucket, and what I have in there is pieces of iron. I found a metalworks place that will save their scrap iron for me, and then I pay them a little bit of a fee, and I use it to treat my waste. This is copper that's cemented out onto these pieces of iron in here. You can see it's highly contaminated with other metals, so I don't have any intentions of trying to recover this copper and reuse it. What we'll do is just I'll end up just rinsing it all off real good and tossing it. We're going to add a few more pieces of iron in here. This is my silver refining stock pot, and all my silver refining waste goes into this bucket, and it's got pieces of copper down in here, and any precious metals that remain in my silver refining wastes cement out onto the copper into my silver refining stock pot. I keep silver out of my gold refining stock pots, and I try to keep gold out of my silver refining stock pots. So now what we're going to do is we're going to siphon this liquid out of my silver refining stock pot, which is just going to be copper in solution, down into my waste treatment bucket. Here we go. Here you can see the pieces of copper that are down in my silver refining stock pot. And those copper pieces in there will serve to cement out any remaining precious metals that are in our silver solutions. Could be gold, could be platinum, could be silver. So we want to get all that out of there. And now that I've transferred all of that solution into my waste treatment bucket down here, we're going to take this back out and set it outdoors now. These are the two solutions that I've precipitated the silver chloride out down in the bottom of these beakers. This is from the copper in quart video that I just did. This is from a gold filled video that I did a few weeks ago. I dropped the silver chloride out of there with hydrochloric acid. So now we're going to add both of these solutions down here, down into my silver refining stock pot, because both of these solutions could still contain other precious metals other than silver, actually. So we want to get any of those precious metals out of these two solutions and cement it out onto the pieces of copper down here in my silver refining stock pot. Here you can see that there's lots of excess nitric in there. It's already starting to react with that copper. That's okay. What I'll do is I've got some copper down here. I bought this about 3 years ago, and I use it for refining silver and waste treatment purposes. And so what we'll do is we'll add a couple more pieces of copper to this bucket. And then now what we'll do is we'll take this out, put it under a rain cover, and let it react outdoors because it's going to produce some fumes. Now we're going to transfer these little bits of silver chloride down into a smaller beaker. Here's our silver chloride from our last two projects. The copper inquartation. We precipitated out that silver chloride with some hydrochloric acid. Now what I'm going to do is rinse this off and get most of the blue off of there. Here's the silver chloride that we just recovered out of those two large beakers. And then here is a jar of silver chloride that I have, that I keep whenever I have some silver solutions, when I'm doing some testing to test for silver chloride and some rinse solutions. I accumulate it in this jar, I keep it under my sink, keep it out of the light because it is light sensitive. Light will turn it dark, and we don't want to let this dry out. If we have this, we want to keep it moist in order for it to react properly. So I'm going to set this back out of the way, and what we're going to do is transfer it into this heavy beaker for our next reaction. This stuff is just really messy, spatters everywhere, so you really got to watch it when you're working with it. There we go. Try to rinse this out with you don't have to use distilled water here. You can use tap water because we're already converted to a chloride, so it doesn't matter if we have chlorine in our rinse water. Now this will make 3/9 fine pure silver if you do it right. You don't have to, you can use this method to make high purity silver. You don't need to run a silver cell if you do it this way, if you do it right. I prefer the silver cell because I like the pure silver crystal. Here you can see there's still a little bit of a blue color left in there, and that's okay for our purposes for this video because I'm going to make this silver for, I'm going to run it through the silver cell. But if you want high purity silver from your silver chloride, then it would be best to rinse it free of all the copper that you could, so that we had a nice clear solution on top of this silver chloride. Now what we'll do is we'll use sodium hydroxide to convert the silver chloride in here to silver oxide. I've got a blender here that I bought at the thrift store. It's perfect for doing this. What we'll do is just reach down in here, get some sodium hydroxide in a scoop, and add it right in to our silver chloride, and this will convert it to silver oxide. Now we're going to get down in here with our blender. I found that this blender is excellent for making sure we got a good mixture here. What we're looking for is a black color, and that'll tell us that all of the silver chloride has been converted to silver oxide. Here you can see on the camera that the silver has got a little bit of a gray tint to it. I'm adding another scoop of lye. I mean, I think you can add too much lye and it will form silver hydroxide. So you got to watch what you're doing with this. You could go a little bit too far. I'm not sure what happens if it turns to silver hydroxide. I don't know how to remedy that. Here we go. Let's stir this up with our stirrer. See if we can get this black. Looking for a nice jet black color. Pretty close to what we're looking for. I'm going to add just a little bit more sodium hydroxide, see if you can see any kind of color change from that. I really can't tell a big difference in color after adding that little bit of lye right there. I think we've got it. Alright, this next part, what we want to do is get the beaker with our silver oxide in it. I'm going to move it down into a clean 5-gallon bucket for this next reaction. Now we're going to convert the silver oxide in here to, see, we got 65 Celsius, 150 Fahrenheit, and that's just from the lye reaction going on in there. We're going to use sugar, granulated sugar, to convert the silver oxide to pure silver metal. Here goes the first spoon in. You got to add this real slow. And I mean real slow. If you pour this in there too quickly, what'll happen is it'll erupt like a volcano and send hot silver and hot solution, spatter it all over on you. So I just added in a few spoons at a time. And you'll see this thing should start boiling in a minute. It's a very exothermic reaction here. (93°C), 200 Fahrenheit. There it goes. You see that boiling? That stuff is no joke. 219 Fahrenheit, 104 Celsius. 105 Celsius, 222 Fahrenheit. And I put it in that bucket to prevent it from boiling over. There it is, 228 Fahrenheit, 108 Celsius. It's a very hot reaction, very exothermic. 109 Celsius, 229 Fahrenheit. I'm just going to let that react for a few minutes. I don't want to overdo this and cause it to overflow. Put another spoon of sugar in there and see what happens. I think the reaction's slowing down a little bit now. Whoa, 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 whoa. There it goes. There we go. 232 Fahrenheit, 111 Celsius. Now you see why I did that in the bucket. It could come up over the edges of that beaker. I can feel the hot silver down in there. When I stir it, it seems to light that reaction off even more vigorously. Whoa. 223 Fahrenheit, 106 Celsius. Thing don't play. It will burn you. I think we're pretty much done now. Let me put another spoon of sugar in here just to make sure. Yeah, I can tell by that red color that we're getting right there. This reaction is complete. Ooh. Still plenty hot. Like I said, this will make 3 nines fine, pure silver, if you take the time to rinse all the chemicals off of the silver chloride, get it nice and clean. And next step is to get the caustic solution, the caustic sugar solution, rinsed off of here. Get down in here and get this up out of our bucket and put it up here so we have a look at it. Here you can see the pure silver. Looks like cement silver down on the bottom of this beaker. And that red solution on top of there is probably some copper compound that reacted with sodium hydroxide. So now what we're going to do is we're going to rinse all this red liquid off of here into our rinse bucket and get our pure silver out of there. What we're going to do now is just use some boiling tap water, and we're going to rinse off the silver and get all that red liquid off of there. Pour it into this waste bucket carefully. A little bit of the silver will get poured over with it. That's okay, we can recover it out of this waste bucket later on. Not much, we'll go over. Just a little. And now what we'll do is add some boiling tap water. And what I'll do is just rinse it over and over with boiling tap water until I get all that lye and sugar rinsed off of there. Alright, here's what the cement silver looks like in there. Ouch. Alright, we're going to keep rinsing this off with some boiling tap water. And I can tell when it's getting all the junk rinsed off of it. When the silver starts to suspend in the rinse water like it's doing right now. And that's letting me know that I'm getting close to having all the lion's sugar rinsed off of it. And what I think we'll do here is we're going to call this, it's getting late, I'm going to call this a part 1 again. See how that silver powder's tending to suspend in that rinse water? And that's how I can tell when I've got the got all the lion's sugar rinsed off of it. Got to watch it here, it'll slip out on you into the waste bucket. And what I'll do is, when I think I'm close to having it all rinsed off, I'll check it with a pH test strip to make sure that the pH is close to neutral. And the reason that's important is because if you leave that lye on there, when you put it in a melt dish to melt it with a whole bunch of lye on the silver, molten lye will dissolve silica. It'll dissolve the melt dish and make the silver real ugly. So we want to get this all completely rinsed off and tested to pH neutral before we dry it out and try to melt it. Okay, so here's our pure silver that we've got down in our waste, or in our beaker. This is high purity silver, be close to 3 nines. Like I said, I had some other metals in there, so it's this particular batch will not be 3 nines. Well, it probably will be close to 3 nines, but if I was going for 3 nines, I would have rinsed it, filtered it, and cleaned it up a little bit better before we did the silver chloride conversion. Anyway, this will conclude part 1 of the silver chloride conversion with lion's sugar. Thank you for watching.